Assalamualaikum and hi everyone. This is me and my group members here. We are from section 9 group B and we are given a task regarding material handling machine configuration B, which is left and right distribution. My name is Mohamad Redzuan and this is my group members list name. Now, let's take a look at the introduction of our design project. As for the background, material handling is the process of loading, unloading, placing, or manipulating material. Types of material handling include product or part or component transfer, packaging, and palletizing, and uses a wide range of manual, semi-automated, and automated equipment. In this project, the materials are being modeled by a packaging box to simulate part of the actual industrial production line process. The objective of our project is to design a material handling machine resembling a production plant that will convey and handling packaging boxes from vertically arranged position to a horizontally moving platform where the boxes will be distributed to the left and right channel sequentially. So, these two figures show side view and plan view for the project. As we can see, there are 3 boxes that will be distributed from a vertical feeder to the moving platform, and finally, the boxes will be separated to the left and right 90 degree alternatingly. Now, moving on to the product design specification. For this box handling machine, this machine can separate boxes alternatingly 90 degrees with respect to conveyor. This machine also has the ability to process 3 boxes in 30 seconds without human operator. For the carton box, we use standard packaging box where the length is 11 cm, width is 8 cm, and the height is 9 cm. There will be 3 boxes per 30 seconds. For the conveyor, we use PVC tube or tire tube. The length from feeder is 70 cm and the width is not more than 15 cm. For the vertical feeder, we use hollow steel. The distance from feeder bottom to conveyor is about 11 cm and the length will be 12 cm, width 9 cm, and it can be at any height. For the ergonomics, the height of operating table is 75 cm. The total height of machine from floor not more than 160 cm, and it should not have sharp projections or opening. For the power, we use a motor with low speed and high torque. The maximum quantity for our motor is 3, and the motor will use direct current powered motor. As for the market, it will use in small industry with packaging line. As for the cost, the total must not exceed 100 ringgit. That's all.
So this is Hazim design. It can be separated in 3 major parts. The first one is the power distribution, where the motor turns the main shaft and the connector belt convey the power to the conveyor belt and the separator. The second one is just the basic conveyor belt concept, where it turns the main wheel, free moving roller, and it turns the conveyor belt. The third one is the separator, where the connector belt turns the straight bevel gear, and using the scotch concept, it allow it to move left and right. So this is overview, and like I say, it works in a simple way where the motor power both of the system, and this allow the separator to move left and right accordingly, and this is the real life illustration of the design.
So we're moving to Faiq's Idlan design. So this is the power distribution system. As you can see, we have main shaft, back shaft, and the front shaft. So the back shaft, so first the main shaft is where the power distributed from the motor to the shaft, and then it will be distributed to the back shaft and front shaft. So the back shaft will power the conveyor belt and front shaft will power the separator. So the separator and the conveyor belt will move simultaneously. So next part here, we're moving to the next part, the conveyor belt system. So as you can see here at the back part, you can see the illustration from the main shaft to the back shaft and how the power distributed. So yeah, I think that's it for the conveyor belt system because it's simple. So the next part is we're moving to the next part. So the separator system. So as we can see here, separator consists of bolt, separator, transfer shaft, horizontal bevel gear and vertical bevel gear, because the bevel gear will be used to transfer the power to the separator from the shaft, from the front shaft. Okay, so this separator will rotate according to the power from the motor and will push the box to side by side, left and right simultaneously. Okay, but what is the weakness of this design is that it will not push the box 90 degrees to the side. So yeah, and then as you can see here, okay, I'm sorry, I'll check this. Okay, so this is the real life illustration where the box is from the automated vertical feeder, passes on the conveyor belt and then to the separator, and the separator will push to the side according to left or right. Okay, so yeah, that's how it's look. Again, I remind the weakness of this design, it will not push 90 degrees.
As we can see in Iqbal Putra's design, there's a separator which have motor to make it move upward and downward to separate the box 90 degree using its own time and turns. It used the term seesaw. As we can look in the overall, the box will fall down vertically to the conveyor belt and will move to the separator to separate them left and right within its time and its turn.
The next design is Redzuan's design. There are two parts, which is conveyor belt and separator. For the conveyor belt system, we can see that a main shaft is connected to the electric motor. So, when the electric motor is generated, it will rotate the main shaft. Then, the main shaft will rotate the primary pulley as well as the secondary pulley. It will then transfer the rotation energy from the secondary pulley to the secondary shaft. It will make the drive pulley to rotate as well, and finally the platform will move. For the separator, there is frictionless surface that is connected to the conveyor belt so that the boxes will slide down easily. Now for the separator, it will be connected to electric motor using shaft and gears. So when the motor is generated, the main gear will rotate the second gear. Then the shaft that is connected to the second gear will move to the left and right to control the separator. So this is the overall view or the real life illustration for Redzuan's design.
Amirul's Iman design have two parts, which is one is the separator and the second one is the conveyor belt. Separator consists of the gear system, which has two big gear and one small gear. The gear then will be connected to the platform through a connector. When the gear moves, the platform will open and close accordingly, left and right. Then the small gear will be connected to a motor, which will move the whole gear system and separate the box left and right. Next is the conveyor belt. The conveyor belt has two rollers which located at each end, and one roller will be connected to the motor that will move the conveyor belt system. This is the overall design. The box will be transferred from the vertical box feeder to the conveyor belt, which will move horizontally by the power of motor connected to it. Then the box is transferred horizontally to the platform, which then the platform will open the to the left and right accordingly.
In evaluation matrix, we have weighting and criteria. The more the highest weighting is, the more important that criteria is. Each of the individual will be evaluated by weighting, and we will make a group discussion to give each of the designer a point. That point will be times with weighting and been totaled up to find the designer who have the most highest point. The winner will be referenced in perf matrix. Based on our discussion, Amirul Hazim's design have been the highest point and will be referenced in perf matrix.
Redesign or modified version of Faiq's design, we can see at the end of the separator, he added a slide at the left and right, and the slide will tilted 10 degrees downward so that when the box is transferred, it will fall down easily. Other than that, at the slide, the added features have a thin wall so that when the box is transferred, it will be transferred 90 degrees to the left and right. Iqbal's new design have a new slide which help the box transfer from the conveyor belt to the platform more smoothly, and he added a new platform which will go up and down accordingly when the box is transferred to the platform. Redzuan's design, we can see from the conveyor belt system, which have an upgraded safety system which is more simpler than the last time and use less component than before. And then he added a frictionless surface so that the movement of the box will be transferred to the platform more smoothly. Next is Amirul Iman's design, which he has upgraded the safety system on the conveyor belt. The conveyor is supported with a more stable leg so that when the box is transferred, it will not be shaky. Then he added a barrier to make sure that the box is transferred 90 degrees to the left and right, and the box will not fall off the separator platform.
The modified design that Amirul showed us just now will undergo second evaluation matrix known as pure matrix. There are slightly difference between first matrix and pure matrix. For the first matrix, all the 5 concepts are compared with each other to find a winner. But for pure matrix, the first matrix winner will be the reference, and all 5 concepts will redesign to compete with the reference design. There are the criteria that evaluated, and the concepts will be evaluated using plus, minus or S. Plus means there are improvement in the criteria compared to the reference design. Meanwhile, minus means the criteria is lower compared to the reference design. The S means that there are no difference between the redesign concept and the reference design. Just take a look at Iqbal's redesign concept. The total plus for Iqbal is 6, the total minus is 3, and the total S is 2. To calculate the overall total, the total plus will be minus with the total minus, such as 6 minus 3 is equal to 3. For the real total, the plus and minus will be multiplied with the weighting of the criteria, and then all the values will be summed up to get the real total. And for this pure matrix, the highest real total goes to Amirul Hazim, which is 15, and Amirul Hazim's design will be the final concept for our project.
So this is the final design dimension. The total width of the machine is 40 cm. The total length is 110 cm. The straight bevel gear ratio is 3:1. Radius of the circle is 10 cm. And the length of the internal slide bar is 10 cm. And this is our final design, where we use the compact design and we use the space as smart as possible with built-in moving parts with no exposure, and we also increase the safety by applying an emergency stop button, and we also put the cover to the separator so it will not cause harm to the user. So the end. That's it. Thank you.